Hello, dear students. Today I will go over the two chapters that you must study next week. The first one is about matter. As you can see, matter is anything that occupies space and have mass. And it is in one of these three states: solid, liquid, and gas. You can see here the three states, and you have examples of uh, every state. For example, the solid is rigid, has a fixed number and shape, and you have here some examples, the same thing for liquid and for gas. If you go to the PowerPoint, you can read this very careful, and you can make a difference, or you can make the difference between the solid, the liquid, and the gas state. That's a very important task. Here you have some properties that makes the substance different from other ones. The odor, the color, the volume, the state, the density, the melting point, and the boiling point. These are physical properties. But the physical properties uh, can can be changed without changing the matter. But what happens with the chemical properties? When you change the chemical properties, you are changing the matter, and then you are in front of a new type of matter. Examples of these chemical properties are flammability, rusting of steel, the digestion of food. Of course, when you are burning gas, at the beginning was gas, but at the end you're going to have two different kind of matter. It will be carbon dioxide and water vapor. And of course, energy. We are going to speak about energy in chapter 10. Well, here you have the physical and chemical properties. For example, ethyl alcohol has a boiling point at 78 Celsius degrees. This is a physical property because when you go from the liquid to the gas state, the matter continues being the same one, ethyl alcohol. The hardness of diamond is also a physical property because when you're measuring the hardness, the matter doesn't change. But when you are fermenting sugar, for example, to form ethyl alcohol, well, you begin from sugar, and at the end, what you have is alcohol. And the chemical composition of sugar and ethyl alcohol are quite different. So you go from one type of matter to another type of matter, and that's what we call a chemical property. Here you have examples of physical change. You have here the three states of matter. Here you have what is a chemical change. And here you have an example when you make the electrolysis of water. When I say electrolysis, is that the electric current makes changes into the water and decompose it into oxygen and hydrogen. This is a chemical change because you begin from water And at the end, you have two different forms of matter, oxygen gas and hydrogen gas. Here is a representation of this decomposition. And here you have a question about what is a chemical change? And you have that burning of wood is the only one that is a chemical change, because you begin from wood and at the end you have different substances when you burn it. And you have more exercises. You can go one by one. Well, let's stop into here. What is an element? Elements are all the ones that you can find in the periodic table. Water is a compound because it's made by two elements, but the ratio of the elements in this substance is constant. And the same thing with carbon dioxide and with table sugar. This table sugar is made of 12 atoms of carbon, 22 of hydrogen, and 11 of oxygen. These amounts are constant in this substance. Then we can say that elements and compounds are pure substances. When you have more than one substance together, you make what we call mixtures. Mixtures can be separated into the pure substances, but we can divide them into homogeneous that are that has the same composition in every part of the mixture, or heterogeneous that you can watch with your eyes the different parts that make the mixture. For example, when you have sand and water, you can see what is sand and what is water. But when you dissolve sugar in water, you cannot distinguish what is sugar and what is water. That's why this is a homogeneous, while sand and water is a heterogeneous mixture. Okay, here you have exam questions, and very important. These are the separation based on physical properties of mixtures. The boiling point can be used to separate, for example, water from alcohol, because water, the boiling point of water is 100 Celsius degree, while the boiling point of alcohol is lower. Then when you begin heating the mixture, the first element, a compound that will goes to the gas state is alcohol. And then you can separate it from the water. Also, you can use filtration. For example, when you have sand and water, you can filtrate the water, and the sand remains in the filtering paper. Also, you can use chromatography to separate different substances. This is a technique that is used in chemistry to separate substances according maybe by the solubility in in a liquid, and also you can separate substances by the molar mass. Volatility is using the evaporation. Here you have an example of how to distillate uh, water that contains salt. Then you can separate the water and the salt remains in the um, flask. Here you have a technique for distilling of salt water or distillation of salt waters. That is a homogeneous mixture. This is the way that salt is obtained. You can put the water, the seawater into a pool. The sun evaporates the water and the salt remains in the pool. Then this salt can be processed later and is the one that we use at home. Here you have the filtration. For example, in order to separate salt, sand from water. And here you have the organization of matter. Matter can be homogeneous mixture or heterogeneous mixtures, and there are physical methods to separate the pure substances. The pure substances at the same time are divided into elements and compounds. Compounds are made of different elements, but in a constant ratio. Well, let's go now to energy, that is chapter 10. In chapter 10, first of all, we are going to see what is energy. Is the ability to do work or to produce heat. And the law of conservation of energy established that energy can be converted from one to another, but can be neither created nor destroyed. The total energy of the universe is constant, as matter is also constant. We cannot create matter or destroy matter, only transform into different kinds of matter or energy. The energy can be divided into potential energy that depends on the position. Here, for example, this ball that is at a higher altitude contains more potential energy than the one that is in the bottom. Kinetic energy is the energy that produces motion, and for example, this ball that is falling down contains kinetic energy and depends on the mass and the speed of this ball. Well, here you have that the ball A contains a potential energy, more potential energy than the ball B. Okay, what is heat? Heat involves the transfer of energy between two objects due to a temperature difference. Work is the force acting over a distance. Energy is a state function. Why? Because it's a property that does not depend on any way on a system's past or future. Depends on the system's present state and changes independently of its pathway. You can go one way or other way, but what is important is the initial and the final state. Work and heat are not state functions. Here you have the distance travel from one location to another, not as a state function, because depends on a route taken. Change in elevation is a state of function. Because changes in elevation. Well, temperature changes, for example, in hot water at 90 Celsius degree, the molecules can move randomly, while in cold water at 10 Celsius degree, the molecules cannot move as they do in the liquid state. Then the temperature makes the random motions of the component of the substance to be different. Heat, well, the flow is a flow of energy between two objects due to the difference of temperature. For example, here you have water at 90 Celsius degree and water at 10 Celsius degree. Of course, they will the heat will go from the hot water to the cold water until you get an equilibrium, and both water will have the same temperature at the equilibrium. Then we can say that heat is the flow of energy between two objects at different temperatures. Well, what is a system? It's part of a universe on which we wish to focus our attention, and the surroundings is everything else in the universe. This is an important concept. For example, in a chemical reaction, you go from reactants to the products. In this case, when you go from these reactants to these products, the energy is released to the surroundings. In this case, we are in presence of what we call exothermic reaction. And as you can see, the potential energy is higher in the reactants than in the products. The difference of this energy is the one that is released to the surrounding as heat. Then the endothermic process is when the heat flows, when the heat flow is into a system. Then the system absorbs energy from the surroundings. And this is very different from what we call exothermic process, that the energy flows out of the system. The energy is gained by the surrounding and is equal to the energy that is lost by the system. This is a very important concept to distinguish between an exothermic and an endothermic reaction. Here you have a concept check. You can study this. You can do all these exercises. You have the answers. Okay, we can say that thermodynamic The thermodynamics is the study of energy, is part of chemistry. And the law of conservation of energy says or goes into what we call the first law of thermodynamics. And it established that the energy of the universe is constant. The first law of thermodynamics says the energy of the universe is constant. You cannot create or you cannot destroy energy. You can change from one form of energy to another one. And the internal energy E is equal to the amount of heat plus the amount of work. Then you can say that the internal energy is the energy in form of heat or work done by the system or done over the system. The endothermic process is in the endothermic process Q, the amount of heat is positive. Then we can say that it is higher than 0. Then you can say that delta H, the difference of enthalpy, is higher than 0 in the endothermic energy, because energy is gained by the system from the surrounding. While in the exothermic process, delta H, the difference of enthalpy, is lower than 0, is negative, because the energy is released into the surroundings. And when you go from the reactants to the product, then in this case, the enthalpy is negative when the process is exothermic. Here you have that the internal energy is negative when you are in an exothermic process, and is positive when you are in front of an endothermic process. Okay. Then when the system does work on the surroundings, the work is negative. But when the surroundings do work on the system, the work is positive. Look at this. The internal energy is negative when work is higher than heat. Remember that when we were here, we have seen that internal energy is heat plus work. Let's go here. Let's go here. Let's go here. Okay, look at this. Then we say that the internal energy is Q plus W, heat and work. When work is higher than heat, then the internal energy is negative. But when work is lower than heat, you say that the internal energy is positive. When work is higher than heat, then you can say that the internal energy is exothermic, and that in the other case, the process is endothermic because the pros because it's performing work. Let's go into the units. What is a calorie? The amount of energy or heat required to raise the temperature in 1 gram of water by 1 Celsius degree is what we call calorie. 1 calorie is 4.184 joules. Be careful because you're going to use these as a conversion factor in the problem. For example, if you want to convert 60.1 calorie into joules, well, the unit is 60.1 calories. You use this conversion factor in such a way that you can cancel calorie with calorie, and you multiply and divide, and the unit, the answer will be 251 joules. Look at this. The given number has 3 significant figures. So the answer must have also 3 significant figures. If you give me more significant figures, then you are going to lose points. That's why I told you in the last chapter that operations observing the number of significant figures will be until the end of this class. And you're going to lose points if you don't know how to do these operations. Well, this is the last part of this chapter that you're going to study for this or during this week until chapter 5. Measuring of energy changes. For example, amount of substance being heated is expressed in grams. And the amount of substance is represented by N. And it is by M, mass, and it is in grams. The temperature change is expressed in degrees, usually in Celsius degree. That's the temperature. And the identity of substance is what we call a specific heat capacity, is the energy required to change the temperature of 1 gram of substance by 1 Celsius degree. This is the concept of a specific heat capacity. Here you have in this table the different specific heat capacity of different substances. Look, here in this case is expressed in joules per grams per Celsius degree. The amount of heat, Q, is equal to the specific heat capacity of the substance times the mass of the substance times the change of the temperature. Remember this formula because you're going to use it during the problems in this chapter, and it will be also in the first exam. Well, here you have an example of problem. Calculate the amount of heat, Q, that is in joules, by the way. Here, the temperature of this mass, remember, this mass is, Q is equal to specific heat times mass times the change of temperature. In this case, the mass is this. And the change of temperature is from 21 to 39. Then you subtract 39.6 minus 21.6. Remember that the significant figures are also important here. When you are subtracting, in this case, you will see that the change of temperature will be 8.0 Celsius degree. And the specific heat of water, can be found in the table that I gave you before. In this case is 4.184 joules grand per Celsius degree. So you go to the formula, you put all the data here, and you will find that the answer, the amount of heat during this change of temperature is 471 joules. Look at this. The given numbers has 3 significant figures, 3 and 3 significant figures. That's why you report 3 significant figures in your answer. Well, I hope that you have more a general idea of what you have to study. Thank you, and let me know if you have questions about this task.